event, which is our first public lecture to mark our theme this year, Chemistry and Art. Our summer series of lectures will also have an art twist, and we look forward to welcoming speakers from the National Gallery and the Wedgwood Museum, amongst others, over the summer months. Our chair for this evening's lecture is Quentin Cooper, who is an honorary fellow of the Royal Society of Chemistry. Most famously, he presented the weekly science magazine programme, Material World, on Radio 4, and last year he chaired our lecture entitled Where the Streets Have No Name, in which Paolo Belletta, a driver of the MSL rover Curiosity, explained what they have done on Mars and where they are going next. A slightly different topic this time around, but we are delighted that he has agreed to come and chair again this evening. If you'll please join me in welcoming our chair, Quentin Cooper.
Thank you, and good evening to everybody watching online as well. Thank you to Jonathan for doing all the housekeeping. I always feel it's a slight shame when I come here and he talks about, in the event of a fire, we would exit through the Geological Society. I'm always disappointed. The idea of going back through time to escape from a fire is very appealing. So if I keep doing these, I may one day start that fire myself. So I am, as Jonathan said, I am your host for tonight, or perhaps referee or adjudicator might seem more appropriate given this rather dramatic title we've got. Extreme collaboration when chemistry and art collide. It makes it sound like a grudge match, a smackdown. It's chemistry, it's art, it's chemistry. And of course, the reality is that chemistry and art are colliding all the time. Not just colliding, but colluding, collaborating, conspiring, connecting. And I think these are all themes that we'll be exploring over the course of this Chemistry Meets Art year here. Just yesterday, I was here, same building, a little earlier in the day, as one of the judges for the Chemistry World Science Communication Competition. And there's an example of art and chemistry colliding, some brilliantly creative ways that people were telling chemical stories to get them to new audiences, some of them fiction, some of them non-fiction. But another example of this. Tonight, though, I am not so much here as a judge, not so much here as a referee, not so much here as an adjudicator. The reason I'm really here was because I inadvertently played Cupid to the fascinating relationship you are going to be hearing about between Tony Ryan and Helen Storey, although perhaps since I'm in the RSC, rather than Cupid, I should say catalyst. As Jonathan mentioned, and I'm hoping one or two of you may recall, for a long time I presented Radio 4's much beloved science programme, Material World, or The Material World. It had an indefinite, definite article. And 10 years ago we did, well, we always were doing interesting items, but we did an item 10 years ago, and one of the people who was listening to that was Helen. And what she was listening to was, among other things, Tony. And what she heard changed the course of both their lives. Now, I could tell you more, but I think having brought them together back then, I think what I should do is bring them together for us tonight. So can you please welcome artist, designer and Professor of Fashion Science at the no, it's not you, Tony, at the University of Arts in London, Helen Storey, and Pro-Vice Chancellor of the Faculty of Science and Professor of Physical Chemistry at Sheffield University, Tony Ryan. That we're mostly just going to hear from Helen and Tony, and I'm going to sit and watch it with the rest of you, and then we'll have some questions and your points at the end. But just to start with, we ought just to talk just a tiny bit about this moment back then. The date is etched in history. It's June 17th, 2004. Helen, do you remember what you heard that made you think, I need to get in touch with that man? Not this man, that man.
I think I heard a combination of a geek and a stand-up comic in the first instance, but somebody I certainly thought would be really open to any old idea, and that's the first idea that I tried out on him when I rang him a couple of days later.
So is it, you just thought, oh, he sounds open-minded and funny, I'll just give him a call and see what he says?
Well, I was looking for someone who had a particular knowledge base. And I had a particular problem I was trying to solve as well, which we'll say a little bit about in the presentation. But I have been working with scientists already for about sort of 5 or 6 years previous to that. And every time it worked, it was because of the human being first. So, and that's when I think those collaborations work best.
And Tony, you've been on talking, I think, as I remember, about artificial skin.
Yep.
during which you were giving grisly recalling an instance of a surgical operation where you'd seen inside your own body and described being absolutely off my face, which was a lovely... I think the first time Radio 4 had heard this phrase, absolutely off my face. But again, but then Helen doesn't really call you about that, does she? So how long does it take you to think, I've got somebody who's a potential collaborator here rather than a potential nutter?
Well, I'm glad you said nutter, because... So I'd done the Christmas lectures 2 years before, and you do get a lot of weird phone calls and kind of green ink letters. So having done Material World, I wasn't surprised to get a phone call. And there were two things. First of all, I had heard of Helen, and I had seen Primitive Streak kind of reviewed in the newspapers and things. So I knew about Helen and her work. But she did have this really, really weird idea. And the question that sticks in my mind is, if two electrons can talk to each other across the universe, why can't a bottle know when it's empty and disappear?
Okay, so you're talking about quantum consciousness in a bottle.
And I thought, so we had this conversation, and
yet you're still here 10 years later.
And the thing is, I am kind of intensely pragmatic and a problem solver, so I always want to solve the problem I'm presented with. So we actually talked about how you could make a bottle shrink as the contents left, and we had a reasonable conversation. And then I went back to the lab and said to the boys and girls in the lab, "You won't believe the conversation I've just had." So that's how it started.
But it's one stage to think, okay, that was pleasant, and I know who Helen is, and she's interesting, and she's kind of, blown my mind a little bit here. That's off my face and blown my mind. There's not all of you left after all this. But there's another stage, though, presumably, before you think there is potential for the two of you to actually do something together, not just have a pleasant chat.
Well, because you've kind of set this up as a kind of a dating thing. So I went back and found the 17th of June and said to Helen on the phone, and we kind of, we spoke on the phone a couple of times, and then we got together inside a month. So it turns out I played hard to get for 9 months.
Oh, really hard to get, yeah.
So anyway, then eventually, we kind of came to Sheffield, and Caroline came too, did she?
No, not the first time, just me.
Just you, right? Okay, so then
you'll introduce all these characters properly in a moment.
And then we had a kind of bunch of people, and we did a preliminary experiment pretty much on that day to get us going.
Okay, I think at this point, having in my low-level way played Cupid or Catalyst, I should do what any good Cupid does and vacate the stage and leave it to yourselves. So I think you're going to talk amongst yourselves to the rest of us for a while, and then, as I say, we'll take some questions at the end. So now I leave you in the hands of Tony and Helen.
Thank you, Quentin. So this was our first day in the lab, and I'm playing it very cool. I decided the glasses aren't good enough, so I'm not wearing them and everybody else is.
Because we were doing dangerous stuff.
You were. But what we were trying to work out in the first instance was what of my world Tony was going to be open to, and given that I wasn't a chemist myself, what of Tony's world I could understand. And by bringing those two things together, whether there was any body of work that we were going to be able to create. We still had hanging over us the big question mark about the bottle, and I wasn't going to let go of that. But here again, there's some materials that we started working with when initially we found we couldn't get the bottle funded.
And go on. So this is what we did get funded. When you put in a big science proposal, you generally have to have an example of how it's going to work, what the results you might expect, and make a hypothesis, and this is the hypothesis you're going to test. So our hypothesis was we could make, our hypothesis was Helen and her team could make beautiful haute couture that we could invest with some chemistry that when we destroyed it by making it disappear, there'd be interesting things happened in essentially this big goldfish bowl. And the disappearing dresses were a metaphor for the disappearing packaging that put us together. Because basically the fashion industry is kind of the uber consumption industry. It's the prototypical disposable because things aren't fashionable next week. So it always, and it's a great dilemma inside fashion itself. So it was interesting from that perspective. And we ended up getting funded to do an exhibition. And this is June to July 2008 in Meadow Hall in Sheffield. And it was great because the management of Meadow Hall thought they were getting an art exhibition, and we were in there saying, you're destroying the world with all this crap you're buying in these shops, stop doing it. So it was really, really kind of under the wire.
Meanwhile, hanging on to the bottle idea, this is as far as we got. Interestingly, it had actually been originally a provocation from Unilever. And about 10 or 12 years ago, they were hiring artists to come into the company and help them think quietly, secretly, but provocatively about notions of how can you be green and still make money. And that's what led to me ringing up Tony, but wanting to try and continue it as much as we could. We came up with an idea of a polymer that once the contents is gone, it reduces into a gel by hot water into a saucer, that the top might have like a sort of pepper pot type arrangement where you could drop seeds and rooting compound. You've got rid of your bottle and you're beginning new life. And I eventually took this back to Unilever, and I think it eventually became another product, didn't it? Yeah. In the end, yeah.
So for those of you who are chemically interested, so this bottle's made from polyvinyl alcohol. Polyvinyl alcohol is soluble in hot water and insoluble in cold water. And you can make a bottle that will dissolve in hot water that when at room temperature will hold surfactant. So it'll hold soap, it'll hold detergent, because all the water molecules are all engaged in keeping the detergent in solution so they don't bother with the bottle. Okay? Now when the bottle's empty, you fill it up with hot water, the bottle dissolves, and when it cools down, it makes a gel, and that gel will support the growth of, in this case, mustard and cress. But the kind of what we'd really love to do is have basil fragranced washing up liquid that you turn into a bowl of growing basil in your kitchen, and like that'd walk out a Waitrose.
One of the things we found actually when we were looking at what we could grow in it and what sort of is that you or me?
I don't know. We need to turn these off if we can.
When we were trying to grow basil, for example, we kept getting reports back that the root, there was only one root and it just kept going on its own, so you're getting no growth at the top. Until we found out that actually if you put some obstructions in the polymer, i.e. the root has to hit something to divide, that you then get growth on the top. And I just thought that was a wonderful metaphor for life. You know, sometimes great things need obstructions in order to be able to exist. All the time in this collaboration over the last 10 years, there have been little moments like this where nature or science has said something about us in a really, really interesting way. This is how we displayed it.
So the exhibition that we showed you had three parts. So this part was in a park in Sheffield, and there's an ornate-looking garden shed that I know my dad would love, and then there's just to get the idea across, there's some conventional washing up bottles. There's some bottles disappearing into the soil, and then there's growing basil in a gel. Again, the beauty of this is, so you start working with an artist, right, to do something to kind of demonstrate an idea. We now have a green wall, green roof project where we can make green roofs that are 1/10 of the density of conventional green roofs, so you can retrofit them to any house without putting any extra engineering in, because of the things we learned from doing this. So it really does provoke, this art-science collaboration provokes new research and new ideas, which for me is just fantastic.
And when I first started working with scientists, one of the things that science funders were really worried about was artists simply illustrating science. So when the Wellcome Trust funded my first project, they said, you know, for God's sake, don't give us a T-shirt with a DNA sequence on the front. They really wanted the artist to kind of get into the microscope of the world, if you like, and respond to it and let the science tell you what to do. And it's been that process, that kind of humbling process of letting science tell you what to do, that's been quite unusual in terms of working as an artist. Great one-liners are also something else that has come up since we've been working together, and this was one of Tony's.
So we were, you know, you're in a room, you're with a bunch of artists, and you're talking about, you know, why things are important. And I just said this: you've got to understand, plastic is precious because it's buried sunshine. Plastic was sunshine 2 billion years ago. And obviously that stuck, so that ended up being the slogan for this exhibition, and was on the wall when we took it to Belfast. It was great to be in a shopping mall, but for me as a scientist to have my name associated with an exhibition in a real art gallery with white walls, right, and little plaques on the wall saying Helen Storey and Tony Ryan, polyvinyl, alcohol and water was just brilliant. And so kind of here's a whole array of dresses, suits, and the logo on the wall in the Ormo Baths Gallery in Belfast. And even better than that, I got to stay in the Europa Hotel, which is the most bombed hotel in Europe.
And for me as an artist, the idea that a project can give you the unexpected is something that I've always wanted to court. And some of the things that came out of doing this, so this, for example, is the buttons on a jacket mid-dissolve. And to me, they look like some new species that's just been discovered at the bottom of the ocean. So the idea that working in this way can take you beyond logical thought and can, it almost lets sort of magic suggest itself to you. When we first started working with a clear plastic, I thought, we're going to be in real trouble here. I, almost set up myself to make the world cry with cling film. I don't know what I'm going to do with the stuff. It doesn't do anything. I can't drape it. I can't do anything with it. But slowly, over about a year, we worked out that if we just forgot its limitations and started doing all sorts of things on it, that it itself would start to behave. And this notion that plastic might take on personality was extraordinary. But in this particular one, we worked out that if we lasered pieces very thinly, and if we loaded up some shapes with red dye and some shapes with black dye, once they entered the water, they first the edges would start to sense the water, and therefore they become motile, and they'd start swimming around the bowl as if they were actually alive. So this wonderful metaphor of something kind of dying and disappearing, if you like, as you dunk it, has this afterlife, or this next life, which is in this bowl of water. And as you'll see later on, this is an incredibly fascinating way to be able to get young people into chemistry without even realising that's what they're actually looking at. So we then went on to make dresses. We set ourselves up as a studio at the London College of Fashion and had 26 days to make 26 dresses. And the reason I like this one is that this was made in about 30 minutes, and it's made out of the rubbish that was left over from the whole of the collection. Yet somehow rubbish becomes really, really beautiful when it's treated in this way. This dress, conversely, took about a year to work out how to do. I know it's barely there, but believe me, it's it had an awful lot of work in it. And this is the one that's covered in stars.
Now you have to remember that the dresses were a metaphor, and they were a metaphor for our waste and our consumption and our bad habits at using up all this buried sunshine and not leaving any for anybody else. Unfortunate, and so we never ever wanted the dresses to be real dresses, i.e. on models. But the media kind of insisted that we had to put a dress on a model, and once it's on a model, it stops being a metaphor and starts being a dress, right? And then you get models like this. So the first picture was in the Daily Telegraph, and then I heard this idea. Go on, you, because this still kind of blows me away.
What, in terms of what we did?
Yeah, and the audacity of what you did.
Well, we worked with a rather incredible creative called Nick Knight, and he's a sort of high-grade experimenter. We hired a sort of warehouse, a bit like a sort of James Bond warehouse, and we had our celebrity hung over on a, whatever you call these things, cage, and slowly lowered her into the water. What we didn't know was how fast these things were going to disappear. So I got into quite a lot of trouble because he sort of looked at me and said, "You've only given me 20 seconds, to be great." And this one disappeared really fast. But what we did then was make a film, which has also got a story attached to it, which is coming next. Do you want to say before or after? The film got us into trouble, basically.
So we're talking about this, and Nick Knight wants to put the dresses on a model and take pictures. And okay, so I'm getting into this world. I'd heard of Nick Knight now. It's a really big deal that Nick Knight wants to do it, and fine, we've got to go along with it. And then, he wants to use a big fish tank and actually dunk a model in the dress in a big fish tank, and the clothes are going to dissolve off the model. And I'm like, this is getting way out of metaphor land here. Okay, this could be pornography. And you've got to remember, I'm the only male in the team, right? So everyone else is female, right? There's Caroline Coates, who's in the audience, who kind of really was the driving force behind putting it together. Helen, the dressmakers, I'm the only bloke. And they all thought it was a great idea. So I went along with it, right? No, and I'm being quite serious now. I'm not being a comedian. I was really concerned, and not least because one of my roles at the University of Sheffield now is to chair the Equality and Diversity Board. And the film you're about to see, we were set up and accused of being pornographers, and I was deeply distressed. Deeply, deeply distressed.
I'm very angry as well.
I'm very angry, yeah. Anyway, we'll play you the film now. But before we do, can you put your hands up, those who are chemists?
Wow.
Okay? Right, you who are chemists need to particularly listen to the soundtrack, right?
Delta G equals delta H minus T delta S, the governing equation of thermodynamics. A polymer molecule is made of many monomers joined together. Their configurational entropy means they adopt the shape of a coil. They are not stretched out along their contour length. The zero-order model for a freely jointed chain is a random walk and has the size of the coil being proportional to the number of monomers to the half power. A self-avoiding walk model, which is consistent with the physical insight as the chain is not allowed to cross itself, as the polymer molecule having dimensions scaling to the number of monomers to the 3/5 power. But in the bulk, we observe the behaviour of a freely jointed chain because there are two competing interactions. The expansion due to excluded volume is compensated by a loss of configural entropy due to stretching. Thus, the intra-chain monomer interactions are screened, and hundreds of chains penetrate the coil of any individual chain. A dilute solution has single polymers exploring a self-avoiding walk, and we approach the 3/5 scale as the polymer dissolves. Polymers enter solution because it reduces the free energy of the system, and normally both enthalpy and entropy are favourable. Monomer-solvent interactions are preferred. Initially, the local concentration of the polymer changes, but the polymer coils do not change their dimensions. They interact less as the solvent intercalates between them, and there is less interpenetration between coils. As there are less and less monomer-monomer interactions, the coil expands to eventually take up the self-avoiding walk configuration under dilute solution conditions. As the local concentration drops from C double star to the overlap concentration C star, the size of the coils increases with the concentration of the 1 to the 8th power for a smooth transition. This behaviour is captured in the Krakatty-Porov worm-like chain model, which is significantly different to the Debye function that describes a freely jointed chain. All of the physics is captured in the concept of the persistence length, the distance over which the polymer is straight.
Right, so those of you who are polymer chemists can vouch for the scientific accuracy of that description of a polymer molecule dissolving. That took me a day to work out, Nick Knight and co. asked for, or can you just send us a whole list of scientific words because we want something that sounds like poetry, right? And that did sound like poetry, didn't it, to those of you who are not scientists? And so they made a soundtrack, and it was horrendous. I mean, it made my flesh crawl. So we had to get the soundtrack right. So I'm sat in my office, and I've got a smart board in my office. So I'm projecting it. The office is dark. I'm projecting it on the wall. And I have to get the pacing right, so you get all of the physics in the video. And then they wanted Helen to record it, because they didn't want my voice, for reasons that are pretty obvious. Okay. And then a PhD student come in and said, "What are you doing?" And I said, "Well, I've got to kind of describe the dissolution of a polymer molecule for this video that's a minute and a half long." And what's the video? So I'll play him the video. So this PhD student sits down. Next thing I know, I've got 12 PhD students in my office watching this film, going, "Oh, and you get paid for this?"
But we were here to also talk about catalytic clothing, so we should whip through
Okay, sorry.
this.
No. Are we ready?
We're nearly there. So the good thing about Wonderland, besides all of this the stuff it's turning about, is you can make children's jaws drop open just with a kind of wonder. And if you can make the difficult beautiful, you're kind of halfway there. And there was something about being able to work with young people that actually in the end took us to the next project, which was catalytic clothing.
And getting the kids, we had kids come out to the supermarket, to the shopping mall to look at the exhibition, and they just sit there and gaze for, well, I mean, they would have done for hours if we'd have let them. And then these frames were the prototypes that we just knocked up in the lab to lower the dresses at 1 millimetre per hour. Right, so there's lots of mechanical advantage. So I'm actually giving a little mechanics lesson here. Not only chemistry, but there's mechanics. You get into all sorts of things because the kids ask great questions. And these things we thought were ugly, Helen and co. thought were beautiful. So we had to remake the prototype 6 times. And my tech was absolutely appalled at these scruffy things because he wanted to build them out of brand new shiny aluminium and polish them rather than go down to the bike shop and get old bike wheels and paint them black.
This is a girl who was actually at one of our Wonderland workshops, and we're not quite sure if it's actually her, but certainly within the workshop we were at, she asked a really interesting question of Tony and I. We were trying to sort of share what artists and scientists working together is like, and it was clear she couldn't see why we were even bothering to explain it. She turned around to one of us and said, "Why don't you just make better use of what already exists?" So this coming out of a sort of 12 or 14-year-old girl's mouth was quite something. And we asked her what she meant by that, and she said, "Well, my footsteps, for example, why don't you capture that energy? Why can't you use that?" And it was at that point that Tony had to leave to come here, actually.
Yeah. That's to the room you had. So I had to come to the room you had your cup of coffee in. And getting the energy out of footsteps, the American Army already does that with piezoelectrics to charge batteries in soldiers' boots. So I told her about that. But I had to come to a frightfully boring meeting of the Faraday Council, which is kind of the physical chemistry section of the Royal Society of Chemistry. So as we were going through the minutes,
No offence if anybody here is on the council.
Well, no, I was on the council at the time, and I served my 4 years. And so during the meeting, I calculated the surface area of my suit. Okay, because if you're a physical chemist, that's the sort of thing you can do. And so I had to assume a density. And I knew pretty much the diameter of the fibres. Okay, so the fibre's a cylinder. So you end up with the surface area of the cylinder, the density. You can work out the surface area per unit mass. You make an estimate for the mass of your clothes, and you get 40 square metres per kilogram. 40 square metres of surface, a tennis court, for every kilogram of clothes. Now, if you're a chemist, high surface area means catalyst support. So let's use people as catalyst supports. So I came back from the meeting absolutely buzzing, back from the Royal Society of Chemistry to the London College of Fashion to say, we're going to use people as catalyst supports. And then I had to explain what a catalyst was and what it does and what's it going to do. I said, I don't know yet. Got to work that bit out. And we went away and worked it out. So I knew about some technology that's on self-cleaning windows. Okay, so a self-cleaning window has nano-titania. So titania is a mineral, a white mineral. If it's nano, so it's smaller than the wavelength of light, it doesn't scatter light, so it doesn't appear white. It's transparent. And it's on windows, and basically what it does is, while the sunlight comes in, it messes about with the electrons, makes holes in electron pairs. They split oxygen into singlet oxygen, a free radical, and that free radical reacts with water to make peroxide, hydrogen peroxide, the stuff that some of you have used to bleach your hair. Okay? And the bleach oxidizes organic pollutants, and on a window, basically it turns organic it turns the dirt into soap, and then when it rains, the window washes itself. And that's how self-cleaning windows work. And in this case, you can also oxidize nitric oxide. Nitric oxide is an irritant to the air pathway in your body, and it's produced in large quantities in cities by combustion in cars. So cars and buses and lorries pump out nitrogen dioxide, as do power stations. And actually, it turns out there's a European limit, and in London we're really above it. So then we got excited. Rather than having it on windows, you can put it on people's clothing, and they're much more efficient as catalyst supports than windows because they have a high surface-to-volume ratio. So you can make people perambulating environmental cleanup agents. Helen found a doctor called Frank Kelly who'd been working on a trial of a product with a manufacturer that we'd found independently. And so this map here is a map of London, okay? And you can see all the roads, and this map is a nitrogen dioxide concentration map. Okay, so basically this is a pollution map of London, and flying's a guilty pleasure for me anyway because it burns up buried sunshine. But it's a doubly guilty pleasure because you can actually see Heathrow Airport in the pollution. It stands out. Anyway, so what they did was they coated walls with paint, right? But first, the blue line on the graph over there is a measurement of over the time of day, the concentration of nitric oxide. And you can see the morning rush hour and the evening rush hour in the data. Okay? Then you paint the walls. The walls eat the nitric oxide, and you get the red line. So in this courtyard, there's less pollution because the walls are eating the nitric oxide, and they rely on sunshine to activate the catalyst to do the reaction. So if you board the walls up, the nitrogen dioxide level should go up again, and that's the green line. It really, really works.
So my part in this was how to take what we already knew was happening and turn it into some kind of textile metaphor. One of the things I was really keen to do, which we hadn't done with Wonderland but wanted to do here, was the idea of taking a research project and allowing the public, not allowing, but asking the public to follow it as we did it. So it's the idea of, would they wear something like this if it existed? What would be the barriers for them using it? And being able to take their responses and feed it back to the science. Normally how things are made and come to market, that kind of conversation doesn't happen until it's virtually on the shelves and being tested. So this was a way of in a way, partly inviting co-creation, but also trying to make sure that what we were doing was constantly being checked by others. Is it worth doing? And that you could ask that about a lot of different types of science. So this particular dress, this one in the corner here, was the first hybrid. So we knew it worked in concrete. We knew that it had been working on urban surfaces to a degree. And so under that dress there is the sprayed concrete. We sprayed it as if it was pearls, and it's got the catalyst in it. So you're breathing this evening, you should sense is slightly purer than it was when you came into the room, or it ain't working. So the idea was to take a bit like Wonderland, put it into a dress, put it into something that was everyday, where you could kind of smuggle some science in under a frock, if you like, and get that conversation going. So this is one of the finished fabrics.
And if we go back one, Hels. And the pattern on the dress is the pattern of your lungs, right? So the kind of bronchia and the so there's always there's subtle things as well as kind of obvious things.
The next job, because the difference between previous projects was, I mean, the very earliest science projects, the internet didn't really exist, and we certainly didn't use it. It was in the very early days. Whether there was a way of being able to talk about research around the world as it was happening, even if they weren't geographically linked to what you were doing and couldn't come to an exhibition. So we decided that what we'd do is take this dress and try and make it into a film and do a viral campaign with it, again to invite the world to make comment on what we were doing. And the film you're about to see is only the length of a Radiohead track, and supermodel Erin O'Connor is wearing the dress, which we're still grateful for. And the idea was to throw it out there before the science is finished and see what the world makes of it. Is that it?
I think you should just play now.
We actually showed our sponsor, at the time, Ecover, the film at a meeting here, just after we'd made it. And I was expecting him to cry or have some great emotional reaction. And he turned around to me and said, "Did you listen to the first line of the song?" And I said, "No." And he said, "Don't have any big ideas, they're not going to happen." and I just hadn't heard it. I've been so carried away with the sort of poetry of it. So I just said, it's an English thing. It's irony. Irony. Nothing's going to happen.
So we already knew that this technology, this titanium technology, worked in architectural contexts, and you can get materials coated with it. You can get it in paint. You can get it on ceramic, steel, aluminium. It works really, really well in architecture. This is a church in Rome, a self-cleaning church in Rome. That would be a nice thing, wouldn't it? And as a lapsed Catholic, I can say things like that. And it stays white because it bleaches itself every day in the sun. Okay? That's why it stays white. Now, how do you get it onto people? That's the question. So we decided that we needed to put it in laundry. We needed to make it kind of a washing product so that it was kind of completely democratic. Everyone could retrofit their existing clothing. And everyone has a pair of jeans.
Everyone has a pair of jeans. One of the bonuses of sharing research as it happens is when you have new findings, you can share them immediately, especially if you're working with something like art or music or fashion. As soon as we heard that denim was the most efficacious surface, Caroline and I knew we'd have to come up with an installation sort of within a week. So we did a jeans amnesty of all the scientists and all the students that were around us. We got all the jeans sprayed and we turned them into fields of jeans and then proceeded to tour them all around the UK and in some of our most polluted spots, but also associated with different science festivals, as a second way, and contrary to the film, to be able to talk to people about the idea of the product.
So there are more pairs of jeans in the world than there are people. So it is the most democratic material as well. It turned out that when we tested the nanotitania we had on various different fabrics, the fabric that actually gave us the best cleaning effect was denim, and it's because of the nature of the cotton fibres. Actually, that they fray means that they have a higher surface area per unit volume than synthetics that don't fray. So there's an immediate advantage there in using cotton. So if everyone in London had a pair of jeans on that were catalytic, it'd give you an active surface area, of half the people would give you 80 million square metres, 80 square kilometres of catalyst support from the people of London wandering around. 80 square kilometres is an awful lot of buildings. Right? You couldn't do it with glass. It has to be with fabric. And they'd be able to take out 40 tonnes of NOx a day, of nitric oxides a day. And this is an electron microscope picture of a cross-section. So you take a piece of cloth, you mount it in a resin, you slice it, then you look at it in the electron microscope, and it's got false colour on, and where it's yellow, there is titanium, and where it's blue, there isn't. So you can see the titanium embedded on the fibres and throughout the fabric. So, obviously, I have to do calculations all the time. We went to China the other day and I calculated the number of ducks that the Chinese eat in a day, which is 50 million. And we know that the UK NOx emissions are a megaton a year, so 1 million tonnes of NOx a year is produced in the UK. So just as a proxy, Londoners have 13% of the UK's population, so they're responsible for 13% of this, which is 130 kilotons. The population of London's 8.2 million, and importantly, the level of NOx in London is twice the EU limit, so it's twice the 40 micrograms per cubic metre limit. So to do that, that means we need to lose 65,000 tonnes of NOx a year in London, which is 180 tonnes a day. And at 10 grams a day, so if all your clothes were catalysed, all the people in London would only do, at most, 80 tonnes. So you could actually, in London, every Londoner being catalytic would only take out about a third of the NOx we need to lose to get to the level. So we'd still have to do a lot more. It's not enough, but it helps. So we are, this is a map of the NOx levels in the UK, right? So you can see the major road networks. You can even see the M74 coming out of Glasgow. The best thing to come out of London, the M1, on its way up towards Leeds. And that little red dot, right, of the highest concentration is where we are now. Okay? So it's a particular problem in London. Turns out for Sheffield, which is in this yellow to orange area here, we're actually only 20% at most above the NOx level. So we need to lose 8,000 tonnes a year, which is 3 tonnes a day, and 10 grams a day per person. We'd only need 250,000 people in Sheffield. So if the population of Sheffield was catalytic, they would make Sheffield air quality compliant for NOx. So we can do it in Sheffield, and on average we can do it in the UK, but London's just too dirty because the population density is so high and there's so much traffic.
So we decided to tell everyone about that in a laundrette. And at last Manchester Science Festival, we did a pop-up conversation with Deepa here. And that, again, was another opportunity to be able to talk about how the project had come to be and get some responses from people who have a sort of an idea of what the product might even look like. That was our outside. I'm whipping through this because I'm looking at the clock.
Okay.
This piece here, what was wonderful about the project was as soon as people started hearing about it, they actually got it. And we now have a massive following who would like this product to exist. And perhaps through the questions and answers we can tell you what our obstacles are, some of those along the way to get it actually onto Sainsbury's or Waitrose shelf. But this is a piece from an archive collection. It was clear we're going to need more collateral to be able to continue these conversations in public. So this is an archive piece which we've sprayed. We then heard from an architectural company. Why are you laughing at them? An architectural firm in New York.
Because I remember the phone call. So
Another one.
So this phone call. So at first I got an email message about the project we were doing, and this was from an architect who wanted to put an installation in the Museum of Modern Art in New York. And he's ringing me up, and he was a very tall, very gay Austrian architect whose favourite phrase was "super cool, yeah." And I know that because Helen and I went to see the installation. This will take out the pollution of 250 cars as they drive past the Museum of Modern Art. And people were kind of at this rave, this outdoor rave in the rain. And I was stood there. I mean, I didn't have a suit on, but I did feel somewhat out of place.
One of the last things we wanted to show you was, it's called a living map. We wanted to try and find a way of tracking what world interest had been on the project. So we managed to track every tweet, every blog, every piece of TV media, and anything that was actually out there on social media, and rendered a map by hand over a 3-month period. This is the little film we came up with. There's been some interest in universities in making that map workable for anybody's research. So being able to put an idea in and find out whether the world thinks they like your idea, make sense of it, or would ever use it. And that's kind of ongoing. The last piece, apart from that, the Royal Society of Chemistry and London College of Fashion have very kindly sponsored me to do another piece, a new piece. And this is called The Dress of Glass and Flame. It'll be at Edinburgh Science Festival next month. And it's basically looking at the idea of the chemistry of flame and the chemistry of glass. I think because we've had such success in producing sort of one-off pieces that generate conversations, we want to keep doing this, but at all times trying to find some level of science that we can explore through it.
I have to teach a new course in a couple of weeks' time. I'm actually teaching a gas phase reaction kinetics, which is good because I'll be able to talk about the flame with some authority once I've taught the course. I know all about glass, I didn't have a clue about flames. So every good team needs a brand, and we've been working with some great artists, and they came up with this brand for us.
You can do it.
So there are two people in the world who don't like this image. One's my PA, the other's my wife. Okay, and Helen's reaction to it is, I'm not that cute, and she's not that foxy. Thank you very much indeed.
Thank you.
Wow, I think that's the greatest amount of nudity and Radiohead I've ever had in a conversation. I was expecting Sheffield, I wasn't expecting York. So you've had a lot of stuff about catalytic. There is now no excuse for being catatonic. So I've got lots I could ask, but I think it's more important we get your points and questions. So I'm going to take the risk. There is a gentleman there. We'll go straight to you.
Well, thank you very, very much. That's the sort of talk that I come to listen. The serendipity also comes into it, because yesterday I was talking with a Chinese friend of mine who was worrying about the smog in China. And we'd got to the stage where she has invented a sort of a thing which could absorb some of the particles and such like, and they're going to stick it on car bumpers or on bicycles. And I'm just wondering whether we can paint or do something with your one of these chemicals to absorb some of the smog by keeping it down, and something else could happen on the rest.
Well, you've read our minds, because we're working with China now on this very thing. One of the things that happened when we did the talks in China was that it seemed that at the end a single figure would stand up and say, I want to do that with you. And at the last talk that we gave, one such girl stood up, and we've been working together ever since. And she wants to lead a student revolution, which she's calling the Pure Revolution. And the first installation of catalytic clothes, which is actually going to be T-shirts for them, is going up in Nanjing in about 2 weeks' time. And Tony's popping over, and then it's going to move to Beijing.
Just so happens that I'm going to be out in Nanjing teaching on a joint course we have with Nanjing Tech. So I'm going to work with them, and I'm going to take the chemistry students I'm teaching across to this exhibition, and hopefully get the art and design and engineering students and the chemistry students to work on this together, and just kind of let them do it.
Presumably some of the gradients you'd be dealing with would be even more extreme than the kind
well...
You'd have to get all the people and all those 50 million ducks to wear denim as well.
Well, interestingly, so the pollution level is directly correlated with wealth, okay? Because energy consumption is directly correlated with wealth. So China isn't that polluted from a NOx level. Okay, so Nanjing actually is only about 30% above the EU limits. It's about the same as Sheffield. And if we catalysed 20% of the people in Nanjing, they'd be able to clean Nanjing up. Right? Beijing's a different matter because its pollution levels are very, very high because of the geography of Beijing, being surrounded by hills. And the main problem they have actually is particulates. It's PM25s and the like. And we can do something about them, but obviously the particulate, so it's a surface chemistry rather than a gas phase reaction.
But presumably you actually get a chance to make a better impression if you can get in there earlier in the pollution cycle.
You know, someone's going to ask the question, when can I go out and buy it? And the answer is we don't know, because we can't get anyone to manufacture it here in the UK, because laundry companies are a little bit risk-averse with respect to nanotechnology and Prince Charles getting on their case and all that sort of stuff. But you could imagine a country like China saying, it will be in your washing powder.
Yeah. And it is done. Yeah.
And it's done. So I have great hopes for China.
Okay, fingers crossed. Next, go to gentleman there, if we may. Microphone's coming in.
Thank you. Fascinating talk. I have a question, regarding the very impressive curve that was showing the reductions in nitrogen dioxide pollution. I think it's all the more impressive, I guess, because it's not happening in a vacuum. There will be turbulence and diffusion that are trying to backfill the space that's been vacated by your catalytic surface. So my first question was, I just wondered how far from that surface those measurements were made.
Just before you answer, can I just say, it's only in the Royal Society of Chemistry where, having seen Erin O'Connor and a partially new model, that when somebody talks about an impressive curve, it's sort of graph.
Well, it suits me.
The other thing I just wanted to very quickly ask was, could you explain what the ultimate fate is, environmental fate, once the pollutant has been catalysed?
Okay, so the first part of the question, the measurements were made in the courtyard of Royal College of Art in Chelsea?
Central St Martin's.
Central St Martin's. So they were made in a courtyard. The data are somewhat flawed because halfway through the trial, a fresh source of nitric oxide appeared locally because a different factory opened. Okay, so it's really, really difficult to do. We've just run a trial in Sheffield where we painted an on-ramp next to a school, and there was an air quality monitoring station in the school. The measurements are made with diffusion tubes, and the diffusion tubes are centimetres from the wall. The second question was, what's the environmental fate of the nitric oxide? So nitric oxide becomes nitric acid. If it's on a wall, that's great, because there's generally calcium carbonate around. So the calcium carbonate reacts with the nitric acid to make calcium nitrate. Calcium nitrate is water-soluble. When it rains, it runs off. So it does put some nitrate. You know, if you take 1,000 tonnes a year of nitric oxide out of the air, you end up putting essentially 1,000 tonnes a year of nitrate into the water system. So there is some eutrophication issues that we would have to think about.
And what about when it's on clothes rather than...
Okay, so on clothes, so you get... the reaction takes place in an aerosol, right? So we don't think very much of it stays on your clothes, because there's a temperature gradient, right? So the gas comes out from you, right? So and you constantly emit, some more than others.
Don't look at me when you say that.
Well, no. Well, only because I can't look at myself. So you're constantly emitting an aerosol, and the nitric acid gets carried away with the aerosol. You do see some damage to clothes. I mean, undoubtedly, you're making bleach on clothes, you're making acid on clothes. You do see some damage, but the kind of damage you see is not lifetime. It wouldn't shorten the usable life of the garment, because most garments are thrown away long before they're kind of full of holes and things.
And actually, possibly, if you market it right with denim, a lot of people want their denim to look intriguingly worn, so if it accelerates it, that might help. Yeah. Okay, next. Don't know what she wants. Go to the lady there.
Yeah, going back to the dissolving dresses, what's the potential to potentially print an outfit, dissolve it up, extract out the polymer, and then reuse it for another bout of 3D printing, so the next day you wear a different outfit?
It's. I don't think you wouldn't want to wear dissolvable clothes for very long. Kind of the arms would go quick and stuff. So I'm not sure that that's viable. But you do see this material a lot. So if you have a dishwasher tab, yeah, that's in where it's liquid in a pouch, it's exactly this material that you're putting in. And we've had all sorts of conversations about could you make the water treatment chemicals that they use in the sewage farm, right, into a polymer, so that actually you put the water, you use the packaging, turns into the water treatment chemicals at the sewage farm, rather than you throwing packaging away and having to add chemicals there. So we've kind of thought of all sorts of things about how we might have multiple uses for materials so that we minimise resource.
Okay, there was another somewhere down there, gentleman there. Hang on, the microphone's just coming in.
Okay. Yes, is there any possibility that the titanium dioxide, which I understand is the catalyst, could cause skin sensitization?
Okay, so it's a very important question, and it's one of the concerns of laundry manufacturers. We have had lots of tests done on skin sensitization, and it doesn't appear to be an issue. So we've already done some of that testing. The same material, exactly the same material, is in sunscreen, and people rub that on their faces. So I don't think having said that, there may well be for certain individuals a sensitization problem, and like with any product, the advice would be don't do all of your garments at once. Do one and try it, see if it works for you, and there's no point in doing your underwear, right? Because that doesn't see the light, so it wouldn't work anyway.
This sort of fits into the question that Helen sort of almost invited the audience to ask, so I may as well ask it, which is what are the obstacles to commercialisation here? We've talked about the relationship between art and chemistry. What about the relationship between your ideas and actually having things that we will get in our everyday lives?
Well, almost without exception, the blocks to it getting to market are actually questions for society as a whole. So what's been good about the project is it started to ask questions of us. So the way the technology works is that as I walk forward, it's the person behind me that benefits from the pure air, and I benefit from the person ahead. So if that's altruism, how do you sell it? And the companies we have been talking to have said they don't know how to market that. They know how to make your skin more beautiful, your house cleaner, but they don't know how to sell you something where the person who's benefiting is behind you first. So that's one thing. But then you think about the state of the world and some of the problems that we have about putting ourselves in the shoes of the other. And just at that time, we have a technology like this that might be able to allow us to exercise or loosen some of those things that actually stop the world getting on. The other thing is it's only need to put on once, or you only need to put it on a small amount.
Yeah. So once it's on your clothes, because the particles are nanoparticles, they stay there forever because van der Waals forces are greater than the mass. Okay, so you only need to treat your clothes once, and the catalyst's there forever. So you only get to sell it once. And if you're selling laundry detergent, so we might need to think about doing it as like a dial-on sort of thing, where you wash them in.
So they want something sustainable that's less sustainable?
Yeah, well, yeah. But so what we do know is, so there are some laundry companies that have trialled this. You get measurable effects. They can treat the particles so that they absorb strongly on garments. There's very little washout of the washing machine, so very little of it goes down the drain. It really works in a room situation. We've done some modelling in a room situation as well that proves it works. The challenge for us now is to put a sensor kind of here on a person that's catalysed, so that the marketing department can say, if you are catalysed, you are breathing in cleaner air. And then they'll be able to sell it, because marketing departments cannot sell altruism. They can only sell selfishness.
But I thought can't you say, here's an idea that's a breath of fresh air, you're the breath of fresh air.
Quentin, believe me.
Yeah, no,
We've tried and tried.
There's another issue, which is you can't sort of brand a part of the atmosphere Procter & Gamble's and another bit Unilever. It works at scale. We've all got to do it.
Yeah.
So in that sense, you've also got to call them up on something else, which is they all have a sustainable living plan of some kind. And actually the only way it will work is if Unilever work with Procter & Gamble, who work with Reckitt Benckiser, who work with Ecova, and they do it for the world, still make a profit. They could all make their own patents on it, multiple types of two-in-one shampoos in different companies. So it's not that they wouldn't make money from it, but they'd actually have to work in a completely new way.
So instead of trying to revolutionise clothing, they're trying to revolutionise commerce, which
well,
might
that's
be...
what I mean. It's a challenge back to them. It's a product that's now asking for a new business model.
And we chose specifically not to patent this, okay? Because it does need to be in every laundry product from every manufacturer in order that we all benefit from the breath of fresh air. So we left space for every manufacturer to use their proprietary deposition technology. But don't think this is a panacea, right? So one reason you can't sell it is that most fabric conditioner, the thing it provides most of the clothing is fragrance. Yeah. And the catalyst eats the fragrance because it can't tell the difference between a bad smell and a good smell. Okay, so fragrance is an issue for them because you end up with clothes that have no smell. I mean, it eats your perfume. You know, if you put aftershave on and you're catalyzed, it's gone.
But then maybe if you succeed with all that basil, everything will smell of basil anyway.
Yeah.
So we won't worry about this. Other question? We've got a question there. Just keeping an eye on the time.
Hi. Very, very interesting. Thank you so much. I wanted to ask about the dissolving bottles. Have you tried with other than detergents, such as, I don't know, milk, or I don't know whether the compounds react with food or not, or what the situation is?
So we've tried, we tried lots of liquids. Basically, if there's any ionic strength in the liquid, if there's any salt there, then the bottle will hold it. The bottle won't dissolve, and the polymer won't dissolve in the product. The issue is this material looks like PET by all of the mechanisms that are used to separate plastics. So it'd be adding a different plastic to the waste stream, and would actually end up making lots of PET no longer recyclable. So there's a good technical reason not to take it to market, because not every bottle would end up being turned into gel. Some of it would go in the bin, and then once it went in the bin, it'd end up contaminating a recycling stream, which is a real shame. But sometimes you do come across these showstoppers. You get all excited and carried away, and then there's a good technical showstopper, and you just have to stop, which is what we've done.
You do still sound like you're both kind of firing off each other after sparking off each other. I mean, like with a lot of friendships, and I presume this is a friendship. Oh, doesn't quite look like the cartoon image, but yes, fine. That's better. But the longer you know somebody, the more they get to know your inner weird. The more you're prepared to talk your crazier ideas. Is this what's happening here? Because you came in on, quantum bottles, so I wonder where you were left to go.
Well, because we came in with ridiculous, it sort of carried on. I think, that's been part of the way of working out whether we could work together or not. So I think going in and asking that first naive question, if that's acceptable, then it can go anywhere after that.
And are you still finding new other?
Yeah. I mean, we did a series of carrier bags that said I use 99% less energy than an eco bag, to kind of challenge people about, because it's always the biggest car in the supermarket car park that has the most eco bags in.
Yeah,
right? You need to use an eco bag 154 times to get ahead in energy terms of taking a new carrier bag every time. So, we had that idea came up. And Helen's contacts meant that we had these beautiful handbags made as kind of carrier bag toppers.
Yeah, I think it's like you referred to your lapsed Catholic status. I always think eco bags for a lot of people are like old indulgences. I've got this, therefore I can have my SUV and I can ignore everything else. But I've got an eco bag, so I'm environmentally sound.
Yeah. So there's at Sheffield we've been running. I run this project called Project Sunshine about returning the economy to a solar-based economy, not a fossil fuel economy, and about transforming agriculture so we don't throw away an important human resource. shit, because it's fertilizer, right? And so I have pictures of a couple of professors of botany in these T-shirts that Helen designed, saying shit happens to me, think and reuse. So I mean, it's constant.
You just like to provoke. Okay, we've got time for just maybe one or two more questions. So if somebody's got a really good climactic question, that would be fantastic. If you don't, I've got plenty of my own, but I'd much rather we had yours. Gentleman there, excellent.
Mine isn't a question, it's a suggestion. Why not, the next time you make a film, use Borodin's music? After all, he was a bloody good chemist as well.
Okay, point taken, we'll do that.
Okay, Radiohead out, Borodin in. I'm not sure it'll play with the kids, but it's fine. Talking of your films, you did sort of say that you got into trouble about it being pornography. Who did you get into trouble with?
Ooh.
And how much trouble was it?
So we were invited to speak at a research away day for another university that was run by someone who'd been involved in a different collaboration with us, and there was some kind of old style 70s militant feminists who took great exception to nudity, and it was seen as being exploitive of women, and I can see that. I mean, I really can see that. Because I show that film to my second year thermodynamics class, because it starts with delta G equals delta H minus T delta S, which is what the lecture course starts with. And I have to make it really, really clear, that all of the people I've worked with on this are women, and they do not consider it to be exploitative or pornographic. And it's a tough call.
Yes, it's not completely without coincidence.
No, you could.
It's almost like a sort of test, isn't it? Because it's like you're sitting there thinking, how many people, when you're sitting there having the properties of monomers described, but you've got these visual images in front of you, are concentrating on the properties of monomers.
Yeah. Well, yeah.
But they'll remember them.
But, they certainly will. And that's presumably, just to bring us full circle, I mean, this is why one of the fundamental things that presumably unites you is you're not necessarily thinking this is art bridging science, but it's about working together to provoke, to change things.
Yeah.
Yeah.
And kind of, I think the one thing we have in common is...
just one?
Well, so the main thing we have in common is it's not enough to do chemistry for chemistry's sake, and it's not enough to do art for art's sake, right? And I've never really thought about that until, Helen said, well, the reason I stopped making frocks and selling them was I wanted to make a difference. And I think doing things like this allows me to make a difference as a chemist that I wouldn't have otherwise made by, measuring the 4th decimal place of the virial coefficient.
Unless you had that kind of video to set it to.
Yeah.
Okay, well, long may the collusion and collision continue. This is where this particular date sort of has to have an end. We've got some drinks coming up in a moment, but before I do, I should have to say, one, having brokered this liaison, I have not had so much as a pair of catalytic Y-fronts out of these two, so I'm slightly disappointed I've not been more appreciated for this as well. But secondly, there's a line from Carl Jung that comes to mind, who said, "The meeting of two personalities is like the contact of two chemical substances. If there is any reaction, both are transformed." Now, clearly, both Helen and Tony have been transformed by each other, and I hope we all have here tonight to some extent. So can we please one more time thank Professor Tony Ryan and Helen Storey.
Professor Helen Storey.
Now, just to say before I hand you over, two things to say. Number one is that there are feedback forms, which we'd be very grateful if you could take the time to put in. Remember, 2 L's in brilliant. And also, just to say thanks to a lot of people for putting this on, particularly Jonathan Wells and Pauline Meekins for setting up. And just to finish things off tonight, Pauline's just going to say a couple of words.
sorry to keep you a bit from your glass of wine, but as some of you know that attend these lectures regularly, this is my last lecture. I've really enjoyed it, but in true Oscar style, I want to say a few thank yous before I leave. Firstly to Helen and Tony, who I first met in 2008 at Wonderland, and I've loved them ever since. I've really enjoyed working with them. Also to Caroline, who's lurking in the back somewhere. It's been great working with you, and I'm so glad you agreed to do my last lecture for me. To Quentin, who always gives a good chairmanship for these lectures and takes our lectures to another level, and I really appreciate, Quentin, you being here tonight. Thank you very much. To Jonathan, who introduced this lecture tonight, Jonathan and my fellow colleagues stepped in very manfully or womanly in the last couple of weeks. I've actually had a family bereavement, so they've stepped in to take over this lecture. Really grateful. Jonathan, you will see more of in the future. Jonathan's going to take over these lectures with the outreach team, who's been setting up and will be here more regularly in the future. Sorry, Lewis, but that's my prompt to thank Lewis at the back as well for always helping us out with the AV, and to his colleague Andrew as well. But mostly I want to thank everybody here tonight for... Oh, Alex, trust Alex. She makes us jump in the office doing that. Everybody here, thank you ever so much for coming tonight. And for those who come more regularly as well, thank you very, very, very much. We started these lectures in 2009. They've been a fantastic success. I'm really, really sorry to be leaving you all. I will come back. I will be in the audience in the future filling out my feedback form. But you've all made it a great success. To those on the internet as well, watching online, thank you very much. It's been a great pleasure to work with you all, and I look forward to seeing you in the future. And I look forward to joining you with a glass of wine in a minute. So thank you very much.